solving systems of linear equations. We are going to, usually when we talk about systems of linear equations, we mean two or more equations. Where does it say that? A system of linear equations consists of two or more linear equations made up of two or more variables. The number of equations is usually equal to the number of variables so that the system is solvable. We're going to see things like this, where we have two equations in two lines with two variables, x and y, right? So as soon as we have two variables, we're going to need two equations to solve this type of system. Usually we begin these sections by checking whether the given point satisfies both equations, which is the same thing as a point satisfying both equations is asking the same question as is 4 comma 7 a solution to the system of equations, because if a point satisfies both equations, that's what we call a solution to the system. And all we have to do here is check whether or not this point lies on both of these lines or curves, depending on what kind of equations we have. Here we're talking about linear equations specifically, so these are going to be lines, and for the whole section as well. So we're checking whether this point lies on this line. The easiest way to do that is just to plug in the x and the y variables and see if the equation is true for those specific variable values. So we plug in 4 and 7 for the x and the y. So in the first equation, 2x plus y equals 15. We're going to plug in 2 times 4 plus 7 and see if it actually equals 15. So I'm going to put a little question mark above the equals. And 2 times 4 is 8. So we have 8 plus 7 equals question mark 15. And then we see that 15 equals 15. So I'm going to put a little check mark above my equal sign, saying that this 4 comma 7 does satisfy that first equation. Now that we know that point is on that first line, we just need to check the second line as well, and then we'll be good to go. So 3x minus y equals 5. Let's see if that one is true. 3 times 4 minus 7. Does that equal 5? Question mark. 3 times 4 is 12 minus 7. Question mark 5. And then 5 equals 5, and I know that's true, so I can put a little check mark above that one too. Once we've checked that both equations are satisfied, that's what the question was asking for, so the answer here is yes. Four comma 7 satisfies both equations, which means 4 comma 7 is a point on both lines. Now these lines, I guess we'll get to what the lines look like in a bit. I don't want to get ahead of myself. So the first type of question you might have is, does a point satisfy both equations? Which is the same thing as asking, is 4 comma 7 a solution? That's what this box is describing here. A solution to a system of equations is any ordered pair, kind of like the 4 comma 7 that we looked at, that satisfies each equation independently. So if it satisfies both, then it is a solution. If it fails to satisfy one of them, then it's not a solution. So if on this first one we found that plugging in 4 comma 7 gave us like 10 equals 15, that means that would be a no, and we wouldn't even have to do this because we know that it doesn't, this point is not on the first line, so then it can't be a solution. It can't satisfy both equations, right? As soon as one of them falls apart, you can stop and say no for the answer. You don't have to keep checking all of the equations in that case. Okay, let's move on to solving systems by substitution. And you already saw how to solve by substitution in the video, so I'm going to go over an example here. Maybe I won't do... Oh, I guess there's only one example. What? Are there more examples later? I guess not. Okay, there's one example for substitution, so let's do this one together. Um, when we want to solve by substitution, the first thing we do is we write one of the equations. This is substitution. This one's substitution. Sorry. We're going to solve one of the two equations for one of the variables, meaning we're going to pick one of the two equations, and then within that equation, we're going to pick one of the two variables, and we're going to isolate that variable. So generally, you want to pick something that has a positive 1 in front of it, kind of like this y or this x, just to make your life a little bit easier. If you were to pick this x here, you're going to have to divide by 2 at some point, and you might end up with fractions. So try, if there is a variable that just has a positive 1 in front of it, the y has a negative 1 in front of it here, so I don't want to pick that one either. But this y or this x, either one of those will work. So let me do it using this second equation here and solve for this x specifically. So I will pick that equation. So x minus y equals negative 1 is what we start with. We're going to isolate the x because it's a positive 1 in front of the x. So how we do that is we add y to both sides so that x equals positive y minus 1. And now I have my tool. I have my equality that tells me what x is equal to in terms of y, right? So I know what x is now, kind of. I know it in terms of y. What we can do is we can take this y minus 1 and we can substitute it into the other equation. So now we jump over to 2x plus y equals negative 8. And we're going to take this y minus 1 and we're going to plug it in for the x in the other equation because that's what x is. X is y minus 1, so I can replace x with y minus 1. So I'll have 2 times y minus 1. So I replace the x. And then we continue writing the rest of the first equation as is. So we have the plus y equals negative 8. Right, now I've ended up at an equation that only has y's in it, which was the goal. So after the substitution step, you should only have one type of variable, right? You shouldn't have x's and y's anymore. You should have only x's or only y's, depending on which kind of substitution you did. So after this, it's just simplifying and distributing and getting the y's and adding like terms together and then finding y. So from here on out, we're just going to find y. So we distribute the 2y minus 2 plus y equals negative 8. The 2y plus y is going to give me 3y minus 2 equals negative 8. And then we can simply add 2 to both sides, divide both sides by 3. Whoa, sorry, it's not 10. Negative 8 plus 2 is negative 6. Divide both sides by 3. And so y equals negative 2. Let me actually move this so we can do it. I guess we'll leave it. So y equals negative 2. Remember, solve the following system of equations means we're trying to find a solution, which is an ordered pair, x comma y. So we haven't really finished yet, but we found one piece of the solution, right? We found the y. So now we want to go back and find the x. The easiest way to do that when you're solving by substitution is we already had an equation that related x and y where x was isolated. So we can take our y here and we can plug it in to this equation. So we'll do that now. We'll take this and we'll plug it into this y here. And so x will equal negative 2 minus 1, which means x is equal to negative 3. And now that we have our x and our y, we can write our answer, which is the solution, is it's going to be an ordered pair. It's going to be x comma y, so negative 3 comma negative 2. That's our answer to the question. Make sure you write it as an ordered pair, x comma y, because when we talk about a solution to a system, we're talking about what point satisfies both of those equations, and this is the form that we represent points in. All right, that's the gist of how we solve by substitution. Now we could have easily, instead of using the second equation to solve for this x, we could have used the first equation to solve for this y, or even if you solve for this x or this y, you should end up with the same point here. The work will be a little significantly different if you choose a different variable to solve for, because you have four choices here. You have this one, this one, this one, and this one that you can isolate from the beginning, right? When I first did this part here, you have a few choices to make. So if you're comparing answers with somebody else, or if you're looking at solutions online for a problem that you did, your work may not look the same, but you should get to the same point here. And this point, if we were to plug in -3 comma -2 into both of these equations, it should satisfy both of them, just like we did with the first example here. Once you have the point and the two equations, you can just plug them in and check if it works. Right? So there's a nice, pretty simple way of checking whether your answer is correct. If I plug in -3 in for x and -2 in for y, do I get -8? And the answer is yes. If I plug in -3 for x in this one and -2 for y here, do I get -1? And the answer is yes again. So we're good here. Okay, any questions? No questions. If you have any questions at any time, you can type it in the chat or speak up. So let's talk about the elimination method, which is also called the addition method in some places. I think the homework calls it the addition method, for example. Why it's called the addition method is we're going to add a whole equations together in order to eliminate something. So it's called elimination because we're eliminating something. It's called addition because we're going to add the whole equation together in order to eliminate something. What we're looking for here for the elimination or addition method is we want a variable like x or y to have the same number coefficient in front of it, but opposite signs. So this x has a 2 in front of it, this x has a 1 in front of it. We could remedy that by, we don't need to write this, we could remedy that by multiplying this equation by a -2, which would place a -2 in front of the x. If we did that, we would have -2x plus 2y equals +2 for the second equation, right? And now we see that the x has a 2 in front of it in this first equation and a -2 in front of it. That's what we're looking for. Okay, I'm going to undo that because there's an easier way, there's an easier one off the bat to look at. If we look at the y's, this y has a +1 in front of it, this y has a -1 in front of it. That's exactly what we're looking for. We're looking for opposite signs but the same number. Okay, and if there isn't one easily available, we can multiply the whole equation by a number in order to make it happen. Okay, as long as you're multiplying both sides, that's a valid operation. So looking at this one, we have a +1y and a -1y. So we're actually ready to just add the two equations together. So we'll draw a line under the two equations and we'll just add straight down. We're going to add these x's together, we're going to add these y's together, we're going to add these numbers together, and we're going to get a single equation. So when I do this, 2x plus x is going to give me 3x. A +y and a -y, because they're opposite signs in the second in the same number, are going to cancel each other out. We're going to get 0 essentially when we add those two together. It's like adding 5 and -5 together, right? That gives you 0. So we get a 0 there, that goes away. And then we have the equals, and then a -8 plus a -1 gives me -9. And then once you've done your addition, if you did it correctly, if you had a positive and a negative version of the same variable, you should end up with an equation that only has one variable because we've eliminated the other one, right? Because there's two variables. Once you eliminate one, you should have one variable left. And then we can simply divide by 3 here in this specific situation and get x equals -3. And so I found one of the variables now. And I need to go back and substitute this into either of these two equations that we started with to find the other variable. So we're going to go back to let's say we go back to the second one. So x minus y equals -1 is what I would go back to. I would say we're going to take this -3 here and we're going to substitute it in for the x that we have, which will give us -3 minus y equals -1. And then we should have a single variable equation again, which we know how to solve. We add 3 to both sides. -y equals 2. To get rid of the negative in front of the y, we're going to divide by -1 or multiply by -1. Either way works. And we end up with y equals -2. And now that we have our x value and y value, we'll write the answer and say solution is -3, -2. This was the same system we solved on the by substitution a second ago, so it makes sense that we got the same answer. So we saw an example of, we saw 3 examples. We saw first example where we just check if the given point is a solution. We solved by substitution, which the word substitution means you are going to substitute for one of the variables. And then we solved by elimination or addition, whatever you want to call it. And in that one, you got to get one of the variables to eliminate by adding the whole equation, the whole equations together. Any questions so far? You guys can work on 2.2.4. Identify what type of solution a system will have. There are three things that can happen when we're solving these systems, and they're described in these graphs down here on the bottom of page 60. There are 3 things that can happen. Because each equation represents a straight line, if I just randomly draw 2 lines on a graph, what can happen is they could intersect in a single point, right? If they cross at all, or the 2 lines could be exactly parallel but shifted away from each other, in which case these lines will go on forever without ever intersecting each other, which means there is no point of intersection. Or the 2 lines could land on top of each other, in which case every single point is an intersection point. Every single point is on both lines. So these are 3 things, the only 3 things that can happen when you draw 2 lines on a graph. So if they intersect that single point, I should make a note of this, the single point of intersection is the solution, because it's a point that satisfies both equations. It's a point that lies on both lines. So when we ask for a solution to a system of equations, we're asking where do the 2 lines intersect. So there are 3 things that can happen. They could intersect in one point, which means there's exactly one solution. They could never intersect, in which case we can't find a solution because they don't intersect, which means the answer is no solutions to something like that. Or they could be on top of each other, in which case every single point on the line is a solution, which means we have infinitely many solutions because these lines go on forever, right? Every single point on this line is a solution, and there are infinitely many solutions. Now, how do we identify these in the form of a system? There are certain things that happen as you're solving the system. There's there are some ways of looking at equations and trying to say, okay, these look like they're going to be they're going to intersect in one point, or these look parallel, or these look like they're the same equation. If you can tell from looking at the equations that they are the same equation, then you know you're in this scenario here, because if you have the same equation twice, that means you have the same line on top of each other twice, right? Or if you can tell me that, how would we classify two parallel lines? What would be the relationships between them that would give that away, that two lines are parallel? Do you guys know? What does it mean for two lines to be parallel? What does that mean about the equations?
Is it when they have the same slope?
Yeah, because they have the same rise over run, right? That's the only way they go up in the same angle. So if they have the same slope, but there's a distinction because these two that were on top of each other also have the same slope, right? Because they have to literally be the same equation. So there needs to be something different about these as well. They have to have the same slope, but they have to have a different y-intercept, right? So they have to be shifted off of each other for them to be considered actually parallel. So by looking at equations like this, if you can figure out what the slope is for each one and you can figure out what the y-intercept is, you might be able to say whether or not they have the same slope and whether or not they have the same y-intercept, and you can tell from looking at that that they will be parallel and therefore will have no solution. But you probably want to know how to identify whether they intersect in one point or they're parallel or they're on top of each other by solving the equations. So as you're solving the equations, that's what this paragraph up here is describing. As you're solving the equation or the system of equations, if you end up with a nonsensical equality like 12 equals 0 or 7 equals 5 or anything like that that doesn't make sense, that is not actually an equality, that means you have an inconsistent system in your hands, which is parallel lines, which, if we look at the graphs, is this example here, where we have no solutions. Okay, so if you end up with somewhere in your solving, whether you're doing solving by substitution or solving by elimination addition, one of the two methods, if you end up with something like this, where both variables eliminate or both variables disappear, then you have an inconsistent system and you could just say no solution because the lines are parallel. So this type of equality where it's not an equality leads to a no solution answer. Okay, and you guys will see this pop up when you're doing examples. I don't necessarily need to show you how to solve this again because we already know how to do that. Hopefully, I just did examples where we solved both ways. So this just says solve the following system of equations. You can use any method you want. When it just says solve the following system of equations, use either substitution or elimination. I don't really care which method you use. If the question doesn't say to specifically use substitution or specifically use elimination, you can use either one. Now, that doesn't mean you don't need to know how to do both of them, because on an exam or I guess quizzes you don't really show work, but on an exam, I will ask you to do it one way or the other, and you have to be able to do it the way that the question asks you to do it. So make sure you know how to do substitution and elimination. The worksheet for today is really good for that because there are questions where it asks you to do it by substitution and then questions where it asks you to do it by elimination. So make sure you practice both methods. So first thing that can happen is you get an equality that doesn't make sense, which means the answer is just no solution. You can stop there and say no solution because they're parallel lines. Another thing that can happen is an absolutely true equation could come out as a result of your work. So if you end up with a 0 equals 0 or like a 7 equals 7 or a 12 equals 12, if you get an equation that is always true, that is what we call a dependent system. And this is the one where the lines are on top of each other, so we have an infinite number of solutions. So this one is infinitely many solutions. The thing I'm writing in red is what you would write for your answer. You say infinitely many solutions, or if the question is asking what kind of system it is, you can say dependent system. Or if it's like multiple choice, a dependent system is one of the choices. That's what this means. What this means is that the lines are on top of each other, and therefore every single point that satisfies one equation will also satisfy the other equation. So they're the same line. This happens when the two equations represent the same line. Okay, so three things that can happen when you're solving. You can solve all the way either using elimination or substitution and find x and y, which means you get a single point. Right? That's the first thing that can happen. Do we have a thing for that? No, we don't. So on these graphs, let's write some things. The first thing that can happen is you solve and you get a point. You find the x value, you find the y value that works for the equations, and that means you're in this situation here where the lines intersect in exactly one solution. That one is called a consistent system. And the solution is x comma y, which is the intersection. The second thing that can happen is this scenario where the lines are parallel, and you end up with something untrue, like 7 equals 0. And you say, no, it's not. And you say, this is an inconsistent system. And then you write no solution. Or, as you're solving, you end up with an absolutely always true equation like 3 equals 3. I'm putting IE in front of these because they're not always going to be 3 equals 3 or 7 equals 0. It's just something that doesn't make sense or something that always makes sense, right? So if you get something like 3 equals 3, then that is a dependent, you said dependent, right? Dependent system. I would suggest you learn the names of the three types of systems. There are things that make it make sense. Inconsistent system is called inconsistent because this equation that we end up with is an inconsistent thing, right? It's never true. These types of systems where the lines are on top of each other are called dependent systems because the answer x comma y depends on where you are on the graph. Because if you're down here, then your x comma y is one thing. If you're up here, then the solution is something else. So there are many solutions, and it depends on which x value you want to choose. If you choose an x value over here, then your y value depends on the x value. If you choose an x value over here, then your y value is different. So that's why it's called a dependent system. And then this one is called a consistent system because no matter how you solve it, you'll consistently get a single solution. The solution will always be a single point. Are there any questions? Okay. You have a few things to work on. You have. Let me